We have 3 updates on the Tri-Eye Atlas object and possibly the best chance to see the third interstellar object ever discovered in our solar system. The European Space Agency recorded something around Tri-Eye Atlas that should not exist according to our current understanding of comets. Images from the ExoMars Trace gas orbiter reveal a blurry, glowing spot, behaving unlike any comet ever observed. His negative polarization reached -2.77%. An extreme value prompting scientists to rush to rewrite their models. The object loses mass as a gas cloud forms around it due to its heating as it approaches the sun. This interstellar visitor weighs over 33 billion tons, making it 1,000 times more massive than ordinary comets. Yet it shows almost no gravitational fluctuations despite actively expelling gas. The meeting time is perfect, or perhaps too perfect, as this object aligned just 5 degrees off Earth's orbital plane and appeared precisely when Mars, Venus, and Jupiter were positioned for observation. The European Space Agency published these images on October 7, 2025, just days after Tri-Eye Atlas approached Mars at a distance of 18,600,000 miles. The glow around the Tri-Eye Atlas consists of about 2 resolving elements, 2 pixels, each about half the width. What makes these new ESA images particularly remarkable is that they were obtained using equipment never intended for this purpose. Cassie's camera, mounted on the ExoMars Trace gas orbiter, was designed to photograph the surface of Mars from just a few hundred miles away. Nick Thomas, the camera's lead researcher, acknowledged that it was an incredibly challenging observation. The comet appeared 10,000 to 100,000 times dimmer than their usual targets, but they managed to capture something that changes our understanding of interstellar objects. The images show Tri-Eye Atlas as a bright blurred core surrounded by what scientists call a coma. But this is not a typical comet halo. The visible glow extends about 680 miles from the core, which sounds impressive until you realize that the Hubble telescope recorded the same glow extending 4,000 miles when the object was much farther away. This reduction in visible size is not due to the comet getting smaller. It happens because Cassie's camera can only detect the brightest and densest part of the gas cloud. Professor Avi Loeb from Harvard has been actively analyzing these images. His team discovered that the brightness profile of the object did not match that of any known comet. When sunlight reflects off typical comet dust, it creates predictable patterns of light polarization, meaning how light waves align after reflection. But Tri-Eye Atlas breaks all the rules. Its extreme negative polarization indicates that the dust particles of this object are significantly different from everything we observe in our solar system. They may be coarser, uneven, or made of materials we have not yet encountered. Mass calculations make the situation truly strange. Using data from 227 observatories around the world, researchers tracked small deviations in the object's trajectory caused by sublimation, when ice turns into vapor and creates small thrust forces. These deviations turned out to be surprisingly small, less than 50 feet per day of acceleration. For an object that is actively losing gas and visible from millions of miles away, such a minimal push indicates something significant. This object is incredibly massive. To better understand, let's compare it to the well-known interstellar visitor, Oumuamua, which was estimated to be about the size of a football field and weighed around 100,000 tons. Tri-Eye Atlas, with its 33 billion tons of mass, is literally 330,000 times heavier. This is like comparing a pickup truck to an aircraft carrier. The core itself is estimated to be 3 to 5 miles wide, not including the surrounding gas cloud. This massive entity poses challenges for traditional theories. Based on what we know about the density of rocky materials in interstellar space, we should not see objects of that size passing through our solar system. The probability of this is astronomically low, and yet it is here, perfectly aligned with our observation. The chemical composition adds another layer of mystery. The Spherex Space Observatory has detected carbon dioxide extending at least 216,000 miles from the core, nearly the distance from Earth to the Moon. But here's what's strange. Although carbon dioxide is common in comets, its distribution around Tri-Eye Atlas does not follow usual patterns. The gas appears to be emitted in specific jets rather than evenly, which may indicate an uneven surface or possible artificial ventilation points. The trajectory analysis reveals perhaps the most intriguing anomaly. The path of this object is aligned with the plane of the ecliptic of our solar system, a flat disk in which all planets rotate with a deviation of only 4.89 degrees. Statistically, such alignment has less than a 1% chance of occurring by chance. Even more curious is that the direction of its arrival coincides with 9 degrees from the location where the famous WOW signal came in 1977. Mysterious radio waves that some scientists once considered a possible message from extraterrestrial civilizations. The appearance of the Three-Eye Atlas seems almost orchestrated. It passed by Mars when the red planet was perfectly positioned for observation. He will pass Venus at the optimal angle and reach his closest point to the Sun, just as Jupiter exerts gravitational influence for a potential subsequent trajectory. These alignments would be remarkable for a targeted mission. For a random interstellar visitor, they represent almost incredible luck. The Mars Express spacecraft of the European Space Agency tried to capture spectral data, essentially the chemical fingerprint of the object. But the initial results are puzzling. The Omega and SPICOM spectrometers recorded unusual elemental ratios. Initial reports indicated the presence of nickel without iron, which is a nearly impossible natural combination, and scientists are cautious in confirming this until further data arrives. What we observe challenges the fundamental understanding of the formation and behavior of comets. In our solar system, comets originate from 2 main regions, the Kuiper Belt beyond Neptune and the Oort cloud at the very edge of our sun's influence. These areas are cold enough for ice to remain stable for billions of years, but a comet known as Tri-Eye Atlas likely formed around a completely different star, possibly under conditions we cannot replicate or fully understand. Dr. Susanna F. Near proposed an intriguing theory that objects like Three-Eyed Atlas may actually be seeds of planets. Her simulations show that if a large interstellar object enters the gas and dust disk of a young solar system, it could become a ready core for planet formation. Instead of growing for millions of years from tiny particles of dust, a planet can quickly form around this alien seed. If this is true, some planets in our galaxy, perhaps even in our own solar system, may have cores that originated around other stars. At this moment, the object is moving toward the Sun at a speed of 134,000 miles per hour and accelerating. It will reach perihelion, its closest point to the Sun, on October 30th, 2025, passing approximately 60 million miles from our star. This is closer than the orbit of Venus, subjecting it to intense heat and radiation. Scientists are closely monitoring whether this will lead to the fragmentation of the object or significantly increase its gas emissions. The European Space Agency has deployed several means to continue observations. The Mars Express and ExoMars orbiters will track the object for as long as possible. The JUICE mission, exploring Jupiter's icy moons, currently heading to Jupiter, will attempt to observe from another angle. However, delays in communication mean that we will not receive most of this data until the beginning of 2026. NASA's involvement was disappointingly limited due to a government shutdown coinciding with the flyby past Mars. Although the Perseverance rover managed to capture what looks like 3 Atlas-like figures as a trace in the Martian sky on October 2nd, detailed analysis from the Mars Reconnaissance Orbiter, equipped with a high-resolution camera capable of photographing at a resolution of up to 30 miles at this distance, remains unavailable. The shutdown timeframes caused confusion in the scientific community. As Loeb noted, the disabling of public NASA data streams during the interstellar flyby seems remarkably convenient, especially considering the unusual characteristics of the object. Nevertheless, ESA's transparency regarding its data helped fill this gap, and citizen scientists even downloaded and processed some raw images before the official releases. What happens next could revolutionize our understanding of interstellar objects. If the comet Tri-Eye Atlas successfully survives its close encounter with the Sun, it will head back into interstellar space, but not before passing within sight of several major observatories. The James Webb Space Telescope has already allocated emergency time for observations, but the results will be published only after review. The consequences of this event extend far beyond a single unusual comet. If objects like the 3 Atlas are more common than we assumed, it means that interstellar space is filled with massive bodies that we just haven't noticed until now. If such objects are indeed rare, as the statistics suggest, we need to explain why we were lucky enough to see one. And if, as some researchers quietly suggest, this is not entirely a natural phenomenon, then we are witnessing events that could change our understanding of humanity's place in the universe. The next few weeks will be critically important as Tri-Eye Atlas approaches the Sun. Any changes in its behavior, structure, or composition will provide important clues about its nature and origin. Every telescope capable of tracking the comet is doing so, creating the most extensive observation campaign of an interstellar object in history. This story is far from over, and the discoveries are just beginning.